So in my first example, I have an x is going to be produced from the first factor. An x cubed is going to be produced from the second factor, and an x squared is going to be produced from the third factor, if I were to multiply it out, but I'm not going to. So I would end up with, my end result is I'm going to have x to the 6th. If I were to multiply all of that out, I'd have a term in there with x to the 6th. So my degree of my polynomial is 6. Now notice I didn't multiply them out. If it's in factored form, leave it in factored form. To determine the end behavior, I need to also look at my leading coefficient. I get a 1x from the first factor. I get 1x cubed in the next factor, and I get 1x squared in the next factor. So I end up with a leading coefficient of 1. So my a sub n is greater than 0. So my end behavior is, as x goes to negative infinity, my function, it will be going up to positive infinity. As x goes to positive infinity, my function will be going to positive infinity as well. Draw a little sketch. That means I expect to go up over here, and I expect to go up over here. So up, up. So that's just to remind myself. I always do a little picture. Now my zeros come from the factor. I'm going to set each one of my factors equal to 0. So I set the first factor equal to 0, and I get x is equal to negative 2. I set my second factor equal to 0, and I get x is equal to 3, and my last one, x is equal to 1. I'm going to go back and talk about the multiplicity. The multiplicity is this degree right here. Well, if it's missing, then it's a degree 1. So it has a multiplicity of 1 on this first one. The next one has a multiplicity of 3, and then the last one has a multiplicity of 2. Now, I'm just going to erase some stuff so I can get some more space there. Now I'm going to talk about the expected behavior at each one of those. So the expected behavior is based on the multiplicity. I expect anything that has a multiplicity of 1 to act like a line. So if I'm going to act like a line, I expect to pass through at the x-axis. Okay? Any multiplicity of 3, I expect it to act like a cube. So a cubic, which means it's going to pass, but it's going to slide pass. And then if I have a multiplicity of 2, I expect it to act like a quadratic, which means it's going to touch and bounce. Okay? So now I'm going to bring all of this information together and do my graph. So my zeros, because they're all real numbers, ends up becoming my x-intercepts. So I have at negative 2, at 1, and at 3. Now remember, on the left side I expect to end up, and on the right side I expect to end in the up position. I'm going to positive infinity on the left and on the right. At negative 2, I expect to pass. I'm going to pass like a line. At 1, I expect to bounce. It's going to act like a quadratic. And at 3, I'm expecting to pass with a slide. So pass as slide. So now I'm going to bring all this information together. Now I can get some more points on there. I can find points on the graph by just putting those values in there. So anything other than negative 2, 1, and 3, so I can get a second set of points on there if I want it. So I know I'm going to start up, and I know I'm going to pass like a line at 2. So I'm going to make it look like a line at 2. And then I need to come to my next 0. My next 0 says I'm going to come and bounce. So I'm going to make it look like a quadratic right there. So if I were to zoom in on that point, that's going to look like a quadratic. And then when I come back to 3, and not only am I going to pass, I'm going to kind of slide through and then come up. And that's what my graph will look like, give or take, based on what do I expect to all look like. On my multiplicities, my zeros, my leading coefficient, and my degree. How was that? Now, I can confirm this with a sign chart. So let's go ahead and confirm this with a sign chart. So I'm going to go over here, I'm going to write my sign chart. I have x plus 2, x minus 1, and x minus 3. Now I've got to make sure I've got the multiplicities on these correct. So my first one has a multiplicity of 1, 3, then 2. So x plus 2 has a multiplicity of 1. X minus 1 has a multiplicity of 2, and x minus 3 has a multiplicity of 3. So don't forget the multiplicity when you do your sign chart. So my first number on the left is at x equals negative 2. And then I had x equals 1. And then I have x is equal to 3. And those come from my zeros. The other thing I'm going to do is I'm going to write in my intervals. So this interval is from negative infinity to negative 2. The next one is from negative 2 to 1. My next one is from 1 to 3. And then my last one is from 3 to infinity. When I am doing a sign chart, I am chasing whether or not we are above or below the x-axis. So I'm going to choose some x value in that first interval. What do you all want to choose in that first interval? Bless you. What do you all want to choose?
Let's do -4.
Okay. So if I put -4 into the x plus 2, do I expect that to be positive or negative? If I put in a -4 into x minus 1 and I square it, keyword here being square it, what do I expect it to be? So when I see the squareds, I just go along that row and put positives all the way through there because it's squared. Then I put in -4 in the last one, so it's -4 minus 3, so it's a negative number cubed. Do I expect it to be positive or negative? Negative. So my region above or below? It's above because I have a negative times a negative, which is positive, multiplied by another positive, so it is positive, and it is above the x-axis. Is that region from negative infinity to -2, so the negative infinity to -2, did I graph that above the x-axis?
No.
Yep, okay, so let's do the next one. What do you all want to choose in the next region?
0.
Let's choose 0. If I put in 0 in my first one, positive or negative?
Positive.
If I put 0 in my second one, so it is 0 minus 3 cubed, so a negative number cubed, is that going to be positive or negative? Negative. So this is going to be above or below?
Below.
So I come look at my graph. In this region, from -2 to 1, am I below the x-axis?
Yes.
Yep, so that confirms it. Now I'm going to choose something in between 1 and 3. What do you all want to choose?
2.
So let's choose 2. I put 2 in my first factor. 2 plus 2, positive or negative? I put 2 in my next grouping, so 2 minus 3, which is the negative number cubed. Is that positive or negative?
Positive.
If I put in 2 minus 3, which is -1 cubed.
Oh, negative.
So is my region above or below?
Above. Below.
That happens to all of us, trust me. I'm directionally challenged. So I am below. So I come over here between 1 and 3. Am I below the x-axis? Yeah. So then I'm going to choose something in the region between 3 and infinity. What do you all want to choose?
7.
Ooh, 7. 7 plus 2, positive or negative?
Positive.
7 minus 3, positive or negative?
Positive.
So positive cubed is still going to produce?
Positive.
So my region above or below?
Above.
So I come over to my graph. In this region from 3 to infinity, am I above or below? I'm above. So the sign chart helps confirm what we expected to happen. And notice over here how I went from below to below. These right here tell me I'm touching and bouncing because on either side of the 0, it is the same value. So that tells me it's a touch and bounce. Does that make sense? All right. So now that we've gone through one completely, please try to do g of x. Go through this. First thing I'm going to do is figure out what my degree of my polynomial is. Out of my first one, I get an x squared. My second factor, I get an x, and my third factor, I get an x cubed. So I end up with x to the fifth as my one of my terms will have an x to the fifth in it. Now I'm not multiplying it out, but that's what it'd have, because I have an x squared from the first factor, an x from the second factor, and then an x squared from the third factor. If I were to multiply it out, I am guaranteed to have x to the fifth in one of my terms.
So you add them together, not?
Yep.
Okay.
So the degree of my polynomial is 5. The next thing I'm going to do is my leading coefficient. I get a negative 2 from my first factor. I get 1 from my second factor, and I get 1 squared from my third factor. My leading coefficient is then going to be negative 2 times 1 squared, which is negative 2. My leading coefficient is negative. So then I look as x goes to negative infinity and as x goes to positive infinity of what I expect it to behave like. It says x goes to negative infinity. How do I expect my graph to go, my function to go, up or down? So it's going to go to positive infinity. As x goes to positive infinity, how do I expect my function to behave? Is it going to go up or down? I just moved on to a different page. Freaked me out there for a minute. I didn't want to do that. So this goes to negative infinity. So I know, I'm going to go over here and draw a quick little graph. I expect it to go like this, up in this quadrant and down in this quadrant, just to remind myself what that means. So now I'm going to go to my zeros. My first 0 is x equals, I set my negative 2x squared to 0, and I get x equals what? 0. And then I get my next one, x is equal to, and then my last one, x is equal to. What is the multiplicity of 0? What do I expect it to act like then? It's going to be a quadratic shape, and it's going to bounce. So I expect, let me erase that multiplicity part. Let me do this, erase that. So I expect this to act like a quadratic and touch and bounce. So quadratic, and I expect it to bounce. What about x equals negative 1? What's its multiplicity?
1.
And so what do I expect it to act like?
A line.
So line, and then do I pass, okay? The last one is x is equal to 3. What is its multiplicity?
2 as well.
So how do I expect it to act?
Quadratic, bouncing, and touching.
Okay, so now let's bring this all together. I know when x goes to negative infinity, I expect to have started up in positive infinity. As x goes to positive infinity, I expect to go down to negative infinity. Put my zeros on there, so negative 1, 0, and 3. At negative 1, what do I expect to happen? I'm going to pass like a line. At 0, do I expect to touch or bounce or pass? So I'm going to bounce there. And at 3, what do I expect to happen? Okay. So using this information, I'm going to come from positive infinity down to 1. I'm going to act like a line, and I get there, and I'm going to pass through. And I come back to my next 0. My 0 is at 0, and I'm going to act like a quadratic, so I have a U shape, so I touch and bounce. I come back to 3, quadratic shape, touch and bounce, and then I go down. So that's what my graph should look like, based on the multiplicities and what do I expect to happen as multiplicities. So let's do the sign chart to confirm. So I have negative 2, x squared, x plus 1, and then x minus 3 squared. So across the top, I'm going to have my first one, which is at negative 1. I'm going to have it at 0, and I'm going to have it at 3. My first interval is from negative infinity to negative 1. My second one is from negative 1 to 0, then 0 to 3, and then 3 to infinity. Now, the reason I put negative 2 in there is because this entire time has a multiplier of negative. That's why I put the negative 2 there. It's because I need a multiplier of a negative the entire time. And then, what happens when I have something squared? It's positive the entire time. So I'm just going to do positive in that row. I'm going to do positive in this row. So then the only thing I really have to worry about is that x plus 1. That's all I have to worry about. So let's choose something in the first interval. What do you all want to choose in that first interval? From negative infinity to negative 1.
Negative 2.
Okay? So I put negative 2, and the only place I have to worry about it is the x plus 1. If I put a negative 2, is that positive or negative?
Negative.
So what is my region?
Positive. Or above.
Yep. So I come over here, in my interval, from negative infinity to negative 1, am I above the x-axis? Cool. What do I want to choose in the interval between negative 1 and 0?
Negative 0.5.
Negative 0.5. So I put in a negative 0.5. When I put in a negative 0.5, and then the only one I have to worry about is that x plus 1, is that going to be positive or negative?
Positive.
So what is my region?
Below.
So I come over here between negative 1 and 0. Am I above or below? I am below. Cool. Looks like it's working out so well. What about the next one? We want to choose between 0 and 3. 2. So 2, we only put in x plus 1, so is that going to be positive or negative? So what is my region?
Negative.
So I come over here in the interval between 0 and 3, am I below the x-axis? Yep. Okay. Now let's choose something in my last interval from 3 to infinity. What do y'all want to choose?
20.
So I put 20 into x plus 1, and I get a positive number. Am I above or below?
Below.
So I come over here. In this region from 3 to infinity, am I below? Yep. And I knew it was going to bounce because I have a 0 between these two, and I'm still the same sign. I'm still below. And I knew I was going to bounce here because I have a 0 between these two regions. In these intervals, I have a 0 between these two intervals, and they're both below, so I know I had to bounce.
Do you know if it passes, if it's like above, below?
Yep.
Above, below?
Yep. So that is finding the graphs based on the multiplicities of the zeros, the degree of your polynomial in factored form. Well, anyways, in any way, but it's in factored form. Makes life easier if it's in factored form, and the leading coefficient. So there it is in all of its glory. And I will upload this and put it in your guys' classroom. Down. What happened here? Oh.